Let's get started. Thanks for turning up to this live session, looking at probe hidden features. This is session 8 of our WebEx training. Now, I said hidden features. They're not hidden features. Of course, they're not hidden features. They're all there. But they are features that people don't use as often as they might do. They can be quite useful, some of these features. I'm going to go through some of the more obvious hidden features and look at how to configure them, how to get the most out of them, and what they can bring to you. Now, most of these features are in fact actually standard features. There are a couple of features, including the PCAP recording and SCTE35 logging. These are optional extras, but we will be discussing them because people do use SCTE35. It's quite a widely sold optional extra. Let's start. I'm going to start by diving straight into RDP, the return data path. Now, the return data path can be a very useful feature. Again, it's a standard feature. I'll mention all of these as being standard or optional extras as we get to them. But the RDP is standard across all of our probes, from the 1 gig probe through to the 10 gig probe. RDP, return data path. Now, as you can see, there's RDP1 and there's RDP2. So we've got two settings. Let me just make this a bit bigger so we can see that and get rid of that down the bottom. So we have got a control tab and then two setup tabs. Now, this is because we've got two completely independent RDP engines. RDP1 and RDP2 can be used at the same time. They're completely independent, so you can have both RDP engines active, or you can just have one active if you want. Now, before I go any further, I just want to go back. I just want to quickly show you the and the reason I want to show you that that won't work. I need to log in as admin to see this working. RDP can also be controlled from the VBC. That's quite important. This I haven't actually talked about the VBC. Next week will be the VBC walkthrough, but today I'm just going to go quickly to the VBC to show you that RDP can be controlled from the VBC, and this gives you the ability to control every probe and to actually start and stop RDP from the VBC. So this is quite a powerful little addition. So it's not just on the probe, but you can actually individual probes from RDP menu item on the VBC. This means you don't have to go into the individual probes. Nevertheless, you do have to go into the individual probes to set them up. So what is RDP? What is the return data path? Let's look at RDP1. Firstly, look at the mode. 3 modes. We've got relay over IP, record, and triggered recording. So let's start with relay over IP. First of all, I need to select a source. Now, if I'm using a satellite probe, as I am now, I've got 3 of my 4 satellite inputs currently active. So there you can see 1, 3, and 4. I've also got an ASI source that I can use and an Ethernet source. So I can select any of my Ethernet multicasts. So let's select an Ethernet multicast. Let's look at one of my services, Boomerang. So Boomerang will be an individual multicast. And we'll look at that just to show you later. We can select the complete stream, or we can select the individual PIDs in this particular stream. Actually, I'm not sure why that's saying, let's go to Cartoon Network. Oh, that's interesting. I'm not sure why it's doing that. I'll have to look into that. So the complete stream, but if I choose, really is very odd. Hold on. Europe. That's what I should be seeing. There's obviously some mix. I only added the multicast this morning and I didn't check them all the way through. So I've added CNBC Europe as a multicast, and then rather than the complete stream, which may seem a bit odd, complete stream just basically says everything. Now, if I select CNBC Europe, that gives me the ability to select the individual PIDs. So for example, if I was only interested in the video, I could delete my audio PIDs. So I could say, right, I'm only going to forward these PIDs here and do that. And then I relay it over IP. So first of all, I have to give it a destination address. So this is a unicast, obviously, with that address, and a port, a time to live, and timeout. Now, timeout's really important. Why is timeout important? Well, imagine you're sending a multicast stream back to, no, before I do that, let me explain how you'd use this. You'd use this, say you had a probe, say you had a digital terrestrial network and you had probes at all of your terrestrial transmitters. And at one particular transmitter, you were having a problem with a particular stream. It would be really useful if I could go to that probe in that remote transmitter location, select a stream and send it back to my NOC. And that's effectively what I'm doing here. I'm sending it. Now, this could be a PC, it could be a set-top box, it could be a number of IP devices that would record, sorry, not record, but would be able to use a transport stream encapsulated in IP. So realistically, it would be a set-top box or a PC. And I've chosen the management interface as my relay interface. So if I use this setting, then basically I'm sending CNBC Europe. Now, I don't know how big it is. I don't know how big CNBC Europe is. It might be, say if it's an HD stream, it could be something like 7 megabits per second. And if I send that down my management interface, then it's quite possible it would flood the management network. Flood it, and then if it floods the management network, then I would lose control of my probe because no more management messages can get through. So by putting a timeout, so we put a timeout 2 minutes. I can choose UDP or RTP if I want. So I choose a 2-minute timeout and then I activate the forwarding. So now I know that it will forward for 2 minutes and then stop. Doesn't matter what happens, if I lose control, if I lose my management network because it's become overrun with IP packets from CNBC Europe, it doesn't matter. 2 minutes later, this forwarding will stop. If I have still been able to get to my, via the management interface, management network, then I know that I'm not being flooded. So then I can now maybe put this into something a bit more useful, like 15 minutes or something like that. When you first start a relay over IP, make sure that this number is quite small to start with. You can, of course, choose the data network. If you want to choose the data network, that's fine too. You may have provisioned the data network to have a bit more overhead or bandwidth. In fact, well, you will definitely have provisioned the data network to have more bandwidth, of course. Still may have problems. So this actually could be more. This could be more of a problem if you send it down the data network and you interrupt the flow of data coming in the opposite direction. Then you are going to service affecting problems. So that's the forward IP or relay over IP. Then we've got the ability to record. So now we can record CNBC Europe, or we can, let's have a look on SAT1. We can record on SAT1. We can record the whole transport stream on SAT1. We can record it. And we've got a record timeout. Now it says 60 seconds there. Now this is very optimistic. Very, very unlikely that you will be able to record 60 seconds of video, even in standard definition, because the recording buffer probe is actually fairly small. With a standard definition, you might get 30, 35, 40 seconds. With HD, you may only get 4 or 5 seconds. So when you set a record up, then this recording really is quite, that's an overstatement of what you can do. Now, basically, if I just apply the changes and go to control, and now RDP1 is recording, it's not recording, it's idle. It says idle there, and it is idle. So I can start the recording process, and it will start. Now it's recording, and you can see it recording, and you can see it's 7 meg, and it will increase its size. I'm not going to wait until it stops, but I'm going to press stop now. And what happens is now we've got a recording.ts. So now I've got a transport stream that I can basically download. So I can download that, analyze it offline, play it through VLC or a transport stream analyzer or something like that. There's also a text file that gives you some metadata, the time and date it was recorded, for example. And I can do the same on RDP2. I can do exactly the same thing. I could make a recording on that as well. I can delete that recording, or I can basically just over-record it by clicking record again, and then that recording that I've made is over-recorded. There is an exception to this, and I will explain this in a minute, with the SD flash card upgrade. Stop that again. 83 meg. That recording. So that's a recording. I can actually do this remotely, so I can go onto any probe and use the VBC, remember, and set up a recording, record a transport stream now, load it now. But what is even more useful is the ability to do a triggered recording. Now, a triggered recording enables me to make a recording, but only in the event of an error. In fact, it's a bit more clever than that, because I can select multiple errors. I can select up to 3 from this enormous large selection. So I can be making an SDT error, or I can looking at PTS, or I can looking at PID minimum bitrate. So any one of these 3 errors start a recording. Now it's quite clever, because if I go to the control, then you can see it's a triggered recording on RDP engine number 1, and it's now idle. So I'll set that up and start it recording. It's triggered recording and it's idle. So it's sitting there. Oh, actually the trigger's active. So one of those triggers is actually active. I know what it is. It's the PTS. There's no PTS in this particular stream. I really ought to go back and let me change that for something a bit better. EIT, no, there's not going to be any EIT in that. Well, there might be an EIT. Let me select the Ethernet. Let's select CNBC Europe complete stream. Let's go to, let's have a look. So we'll look at CC skips, stuff now, into arrival time error, and let's do a media loss rate error. So we can apply those changes, go back to control and select a triggered recording. So the probe now sits looking at this particular triggered recording again. So there obviously is a problem with this multicast. However, what normally happens is the probe sits and it CNBC Europe into a buffer, and it's continually rotating around the buffer. And anytime one of those trigger, remember it's one of those triggers recording off. What it effectively does is sets a timer, and then the probe will stop recording. And what that has the effect of doing is stopping the recording with the error right in the middle of the recording. So the first half of the recording is actually it's still recording, by the way, up to 100 meg, because we set that as, I think that was what the the recording limit was. I really ought to stop that now. I'm going to stop it anyway. So the error is trapped right in the middle of the recording. The first half of the E is before the error happened. The middle of the recording shows the error actually happening. And then the second half of the recording shows what happens after the recording, after the error has occurred. So it's a really powerful tool. This enables you to trap errors, record them right in the middle of the recording, and then download those files. These can be completely independent. So I could be doing a triggered recording on RDP1, and then I could be doing a relay over IP for, I'm not going to do this because my management network will definitely flood. So the other thing to look at in these setup RDP is what do we do with the recording? So we said 60 seconds or 200 meg, whichever's sooner. Do I protect it? In other words, if I say never overwrite, that means that recording will stay there. It doesn't matter how many errors occur in the future, none of them will overwrite this particular recording. Or I can protect it for 30 seconds. In other words, any errors that happen within 30 seconds will not over-record. But if we get an error 35 seconds later, then it will over-record. Minutes. So 30 seconds, 1 minute and 5 minutes. So I said there was an extra feature. I said about this SD flash card option. Now this probe has the SD card, and you can easily tell because when you look at the data tab and you can see a storage. We can see storage, and this is looking now at the SD card. If you don't have the storage tab, then you don't have the SD. It's a 32 gig SD card. Now the problem with the SD card is that it can only be fitted in the factory, not retrofittable. So if you're selling to a customer and you're selling them the idea of having this 32 gigabyte card, which is really useful, and not just for transport stream recordings, as we'll see, it must be ordered at the time of purchase. You can't retrofit this. We can't retrofit. Need to get that fitted at the time of ordering. So basically, we've got a whole load of recordings here. Now there's some other recordings there, and we'll have a look at that in a minute. But right now, we are looking at a whole load of recordings. I can rename them, I can download them by clicking on them, etc. I can delete them, I can delete all of them. So I've got a means of capturing recordings. Now there is a slight proviso here. Just because I've got 32 gigabytes of storage doesn't mean to say I can make a 31 megabyte recording. I can't. I'm still limited by the buffer size of the probe. So when we go back to the RDP and we see these few couple of 100 meg buffers, then that's still the maximum length of recording. So as soon as I make a recording here, then the probe will that recording to the SD card, but it won't do it until it's finished. Then it will make itself available to make another recording and another recording and another recording and so on. So you can't get any bigger recordings, but you can get a lot more of them. I'm just going to turn this off. I'm going to go back to relay over IP and let that go. To apply the changes. So these are both idle now, which is how I want it. So once I'd started this, so if I've got relay idle, if I now go quickly to my VBC and look at that probe, then it's the 272. There it is, the 272 here. So I can basically RDP engine number 1, RDP engine number 2. So I can start and stop, 1 and 2 there. So it's quite useful to be able to do that very quickly. So the next thing on the agenda is the traffic tab. Not many people pay attention to the traffic tab, but it's really useful, particularly if you're going to be troubleshooting network issues. It contains well, basically, as you can see, it's got a breakdown of protocols, IP protocols. Now, not every protocol by any means, not even close to every protocol, but there is quite a lot there. We can see, of course, we can see UDP, which is very useful, and TCP. If we were doing OTT, for example, we'd see our OTT traffic there under HTTP. And there's things like distributed service code. Oh, I forgot what DHCP stands, DSCP. And we've got IGMP, PIM, PIM sparse. So we can see the traffic that's going on the interface, and we can choose either the if we have two data interfaces, we can select either of the data interfaces. So this basically gives us a live indication of the amount of traffic we're getting. And if we're looking at, for example, RTP stuff, and we're doing forward error correction, then we would see our correctable and uncorrectable errors there. COP3 errors. So we can see this data as numbers. We can also see it in bits, and we can see it in frames. And you can see that the actual color of the color of the graphs change. So we look at frames. Let's look at, and we can click on, whenever you see this little bar here, this is showing you that there's a graph available. On the probe, you see these little bars, colored bars. That means there's a graph available. So if I click on that graph, I can now see UDP traffic over time. I can make this wider by going from here to here. I can look at any part, and then I can mouse over and I can see all my UDP traffic at October the 22nd between 11:54, it's gone, 11:54:02 and 11:53:59. So again, I can measure all of this data. What happened there? We saw something just dip down there. So we had a drop, we had no traffic. So you can see immediately between 9:31 and 9:33-ish, just a bit. So for 2 minutes, we lost all of the traffic in this probe. So you can see how useful. You can just spot that. You can spot that on that little graph at the bottom, and you can go in and actually, make it narrower and get a really good view of what happened. These graphs are local to the probe, fortunately. You can see them on the probe. You could do a screen grab if you wanted to do that. But you can't export them. They're not exportable. So they don't go to the VBC, and no third-party NMS can see them either. The graphs are local to the probe, but again, they're very useful. Any TCP whatsoever. No TCP because we're not doing any, well, there's odd little spikes just going up there, but basically we're not getting any OTT traffic. So we're not seeing much. This is just regular bursts across the network. We can look at an OTT probe and see the difference. We'll do that in a minute. And I can clear those statistics if I want. Now there's detect. You may already have seen detect. If we go to the multicasts, there's a detect window there on multicasts. Well, this is exactly the same detect window. It's exactly the same. So it gives me the ability to detect any multicasts on a particular switch. Now, the switch has to be set up to forward multicast to the port that my data interface is connected to on the switch. And also, if I go to the setup, the probe must be in promiscuous mode. Promiscuous mode allows the probe to be able to look at the switch and see what's on there. And if you get some multicasts that you want to see that you don't necessarily know, then you can click and you can add them to stream list. We can add them all, or we can even export them as a CSV file, should you want to. You might want to export them as a CSV. Well, sorry, it's not a CSV file, of course. So it's XML. So this could be incorporated directly into an XML config file. if you wanted to. If you wanted to edit the config file of the probe, you could edit that information in if you wanted to. Much easier just to add to stream list. So filter statistics, this again is another, I'm going to have to go to another probe and show you that. So let's go to the VB330 because there are no filters set up on that. So we go to the VB330. I'm going to go directly to the VB330. Go to. So I can set, on this I've got 2 management ports, so I can actually see the difference in traffic. Have we got any OTT? Yeah, we don't really have much. Don't really have much on here. There's not much OTT traffic on here either. Never mind. So we have some filters. Now we can set these filters up. So we've got multiple filters. We can create up to 50 filters. They're user defined. You can give them a name. Let's just look at one of these. So we need to give it a useful name so that it means something. We need to enable it, and we need to select the traffic type. No filtering on the traffic type, unicast, multicasts. Do we look for RTP headers? Yes or no? Remember, we're building a filter to capture traffic. Do we look at VLANs? Tagged, untagged, specific value. Maybe I'm only looking for VLAN 50. Maybe I'm only looking for traffic that's tagged VLAN 50, for example. IP destination. I can set up a destination. I can set up a destination mask, so I can check all IP traffic going to a particular network, for example, or a host. So we can do IP source. So we can check traffic coming from a source or range of sources, and we can do the same with UDP and UDP payload. And which particular interface. So we can set up quite complicated filters here. Once the filter's in place, close that without making any changes, then the filters are active. The filters are active all the time they're there, and they produce graphs. Remember, we saw these little 3-color bar graphs. So wherever I see one of those, I can generate a graph, and it tells me how many streams have been captured by the filter. So the odd is just filtering odd numbers, odd multicast addresses, something very simple. The odd numbered multicast would be captured, and there are 54 of them. So let's look at the bit rates, for example. This will produce me a diagram that's showing me all the total bit rate for all of the odd numbered multicasts on that interface. And you can read off these numbers. Went down very quickly. We went down very briefly, rather. So we can look at something else. Average stream duration, average stream bit rate. So we can see these sorts of, we can follow this graph. Again, remember, the graphs do not go outside the probe. We can look at the last 90 minutes, for example. So we can go from 4 days to now. Any probe. Cast and any are obviously going to be the same thing. Interestingly, there are no unicasts on this probe. So it's immediately telling me, without even looking, that there are 0 unicasts. So this is local to the probe. It enables the users to set up filters to track traffic. Could be useful or very useful if you're trying to locate a network problem. Now, microbit rate, something a little bit more esoteric, should I say, a little bit more niche. We have microbit rate is basically checking the burst. So let me give you an example. Imagine that we are doing OTT testing. we have a 10 gig network, but we have a probe, a video server attached to a 25 gig network. Now I would make a request, or any other customer can make a request, to see an OTT profile, request to the CDN, and the CDN, because it's a really powerful CDN with a very wide bitrate, can serve this data very quickly. A huge burst of data for one chunk. You know, a chunk might come down in a couple of milliseconds at sort of, you know, 18 megabits per second. And that could, yeah, I mean, you could swamp a 1 gig network card quite easily. So micro bitrate gives you the ability to check and see where your bursts are occurring. And we check these over we check these over 5 intervals. We check them over a millisecond. So in other words, the maximum burst over 1 millisecond, and you can see the maximum burst is 2.7 gigabits per second. And then at 1 millisecond, the maximum burst is 1.1 gigabit per second. And then when we average it over a second, the maximum is 872 megabits per second. And again, you can draw these graphs. So we can change to 5 minutes. You can see the graph basically starts when I click to this screen. So our maximum burst, and you can see all of the, if I mouse over that, you can see that the individual data points occur for the 1 millisecond all the way up to 1,000 milliseconds. So you can read these bursts off. And if I left this going for an hour, then the hour button would appear. I'm going to turn it off now, just because I don't want to look at microbit rate now, and it does impose a load on the probe. So the probe has to do this because it's constantly tracking and drawing these graphs. So if you don't need it, turn it off. Okay, let's look at the Ethernet tab. Some of these, the full service monitoring and Igmp, they require the IP-op. Sorry, not the IP-op. I'm looking at the wrong one. This is a VB220. This is a VB220. So the VB220. The VB220 has it as standard, so I need to find a 120 to show you. A VB120 does not have this as standard, but it does have it as a licensed option. There it is, the advanced Ethernet option. So this gives you the full service monitoring, and it gives you Igmp and a couple of other tools as well. So if we go back, so this, but this is a standard feature on the VB220. So the first thing we see is this full service monitoring. What is full service monitoring? Well, it's an additional tool. Again, not very much used, but in some circumstances, it could be really useful. It gives me the ability to monitor up to 10 IP addresses. So these could be things like a video server, it could be something like an IP encapsulator, anything. Any IP address that you can reach on your network, you can check. And you can just make sure it's alive. So what am I doing? What's it been going? So we're doing a ping. So I'm doing a ping to this IP address, 10.0.205.104. And I've checked it 204 times. Let's interestingly go back to this one and see how long this one's been going. So this has been going for weeks. 69,000 tests. 69,000 tests on these. So these tests, this has been going a long while. So we've been going for 204 tests. 0 fails, hasn't failed once. So it's been able to contact it every single time. Maximum 7 milliseconds, minimum 0.3 milliseconds. So yeah, 700 microseconds, 300 microseconds. And if I want to, I can reset that. It will start again. It will start that up again. So let's look at one of these.
Question.
Okay, let's move on. So you can see we're doing a ping. So let's give this another test. I don't know. Let's call this an IP encapsulator. I'm not very good at spelling, am I? So I can choose. First of all, I need to enable it, of course. I need to choose whether I want to do a ping or I can do something a bit more sophisticated. I can do an HTTP GET. Now, how often do you want me to test it? Well, it's 60 seconds, so every minute I will do a test. Be greater than. Can people turn off their mics, please? Hold on, let me turn off people's mics. Okay, turning off Javier's mic has been turned off. Fine, no problem. So 60 seconds. It must be more than 30. You can see just there. I just over there, and it said it must be more than 30 seconds. So I could set that to 1200 if I wanted to. Test every so often. How many times before I alarm? 4 fails and then an alarm is generated. And then the IP address or a host name and a comment. So HTTP GET, that would be for the ping. So that would be exactly what you got for a ping. If I'm choosing for HTTP GET, then I send a string. So I can send a string. That might be some and then I might be expecting a word reply. I don't know. I might be expecting some reply back, and it would check that word that comes back, you know, for things like spoofing, I guess. I'm not really sure, but I guess that's how it would work. And then I can even have a look and see what was the last content. Well, there wasn't actually anything there, of course, because we haven't done any tests, but I could actually show that. And we can even support cookies. If you want to go really sophisticated, then support cookies, and then you can look at the cookies as well. So we're not going to do that. But that's full service monitoring. And if we go to the alarms, we've got a complete section on full service monitoring. Let me go back to the VBC and have a look. Have we actually had any full service alarms here? So in all that time that these have been recorded, we've had no fails. That's not really surprising because there are other probes on our system. They're not really. It's not really a video server. It might be a Nomad actually. So we're not going to get any errors because these are IP addresses in our system that we know work. Any alarms will appear in full service alarms. They will also, of course, appear down here in the alarms and events. So that's monitoring and that's the setup. You notice also we can do a ping. I could ping an IP address. I don't think I can do it, but let me just test something. That won't work, will it? I'm not sure whether these probes can get to the outside world. Yeah, so it is. It did actually, but it could actually get to Google. So 8.3 milliseconds from google.com. I could even do a trace route if I wanted to. I'm not going to go through this because it takes a while, but I could do a trace route if I wanted to. So again, some quite useful networky tools there. Igmp. We support Igmp version 2 and Igmp version 3. So again, if you're having trouble joining multicasts on a switch, you might want to look at the Igmp traffic that's going to and from the switch. So this would be very useful. We're looking for membership requests and things like that. So there's a membership report here, and there's all the details. Quite useful. Again, Igmp is only part of the Advanced Ethernet option, the AEO. And PCAP. So we saw back in the return data path the ability to record a transport stream. So now we've got the ability to record an IP stream. PCAP, a bit like Wireshark. It's a little bit, well, it's not really much like Wireshark, but it will allow you to capture an IP stream. It won't do any analysis, but it will capture an IP stream and then allow you to download it so you can then do Wireshark analysis on it. Do we want to capture the headers or do we want to capture the payload as well? All non-UDP traffic, so things like Igmp and PIM and all those other protocols, yes. TCP, UDP. And then we can select with using destination and source addresses, so we can add these as filters. And we can select the interface that we record from. So let's do a recording now. Let's actually do a recording. You can see there's a PCAP file there waiting. So we're going to over record that. We'll capture all the UDP traffic and we'll capture just the headers. So just the headers and just the UDP traffic. So I'm going to start that recording. See the speed, the size is going up. And then we'll stop the recording. So now we've got a record.pcap. Now I can download that straight into Wireshark or something similar. Other IP analysis tools are available, and do an analysis on this IP stream. And the nice thing about this as well is because we've got the storage option, we can transfer that file using this PCAP window here. We can transfer that file to SD card. Now you'll notice that the RDP function automatically puts the RDP recordings into the 32 gig SD card, but PCAP doesn't. PCAP will sit there waiting for you to do that. So that's the main difference between PCAP and RDP. PCAP, you have to manually transfer it to the SD card. But then you can do everything else that you need to do. You can rename it, you can download it from here, and you can delete it from here as well. Remember, flash storage is an option. If we look at the about and we look at the license, it's an option, 32 gigabits option, gigabyte option. And it's factory fitted. It is not retrofittable. Okay, I want to show you something else. You may have noticed some additional files. What are these SAT4, SAT3, SAT2, SAT1? What actually are these? CSV, so a comma separated variable, basically a spreadsheet. So what these are, if you remember from when we looked at RF a couple of weeks ago, we looked at the RF and we noticed that all of the RF everywhere, it doesn't matter whether it was cable, satellite or digital, had an RF overview. And we had measurements there. And these measurements were the last measurements when this particular satellite transponder, in this case, satellite transponder, was tuned to. So in the DMOD tuned to this satellite, it made a recording, or rather it made a data entry of all of the parameters, like the level, the maximum level, the signal to noise ratio, modulation error rate, and it recorded those in this table. Well, we now have the ability to record those to our storage card, and that's what these are. So these recordings, again, automatically transferred. These recordings show me all of my data points, so I can pop these straight into an Excel spreadsheet, and I can see exactly how and then I can process them some offline way and see exactly how my modulation error rate, signal to noise, and all of those really detailed RF parameters, how they are changing over time. So where do you set this up? Well, you set it up in this measurement log. So we go to Setup, Measurement Log. Now it's a new feature. This is 5.5 only. It doesn't appear anywhere earlier than 5.5. So first of all, we've got to enable the logging. Again, this is common across all of our probes. We don't want the probe to be doing unnecessary processing if we don't need it. So first of all, we have to enable it. We select the sampling period every 5 seconds or every 2 minutes and things in between. And how long do we retain this data for? So basically, we generate a CSV file that is 10 days long. So basically, we will have 10 days times however many entries 2 minutes takes up. So that's 2 minutes. That's 30 per minute times 60 per hour times 10 days. So that will tell you how many rows in your CSV. And we can do this for ASI as well. It's not just confined to the IP. Sorry, it's not just confined to our RF cards. Now, of course, ASI doesn't have any RF parameters, but it does have PIDs. And see down here, PID enables logging of the PID bitrate, so I can monitor, as well as my RF parameters, I can also monitor my PID bit rates. And again, that can be quite useful. It's just a table of data. It could be useful in certain circumstances. So that's nice to have. And of course, with SAT1, SAT4, I can monitor the PIDs as well. So there's a lot of data here, and it's easily exportable to a CSV file. Now, we talked about, when we looked at satellite, we looked at Gold TS. Now, I'm not going to go through Gold TS at the moment. There is actually a video on the website showing you a big, it's a sort of a 15-minute, no, it's about a 20-minute video on how to set up Gold TS. But Gold TS appears, let's just look at one of these. Gold TS appears down here in the other checks on ETR 290. Sorry, Louise, I've just seen that message pop up. I will address it at the end. We're getting quite close to the end now, so I will address that question at the end. So hang fire, got about another 10 minutes. Gold TS, just in case you don't remember what Gold TS does, Gold TS enables, if we go to the Gold TS threshold, I can select my interface. Typically it would be a satellite transponder, or it would be something like the ASI, or it would be one of my Ethernet ETR engines. So basically I'm asking the probe to take a snapshot of one of these. So satellite is, it's pretty standard. So we're looking at whatever's coming in on our satellite. We're looking at the transport stream, just the transport stream, and we're taking a snapshot of that transport stream, and we're using it as a reference table. Not every table. I think I may well have shown you before, but there are only I can't remember the PMT, the NIT, the EIT. No, it's not the EIT. The SDT actual and other, and the NIT actual and other. Oh, and the BAT as well. So they're the tables that are monitored. So if anything changes, if anything in that transport stream changes, then you'll get a Gold TS alarm. So it's basically basically a reference table. And the great thing about this is when we look at the ETR details, Gold TS is a standard feature. It doesn't cost any extra. But in order to use it effectively, you must make, go back to the overview, you must make, so we were looking at 10747 gig. So we were looking at this transponder. Now, right now, my ETR engine is looking at a completely different transponder, 10903. Got any problems with my Gold TS reference stream in 10747 TPA3, I'm not going to see it. So it's a great argument for getting more RF interfaces, and more ETR engines. Okay, the other thing I wanted to show you is SCT35. We're nearly there now. So it's in the VB330. So if I look at my MPEG ETR290 and I look at SCTI35, SCT35, I've got one stream with SCT35 events in it, and it happens to be the Sky Sport Plus. At 1600 SCT35 errors, sorry, not errors, SCT35 events. It's really important, actually. I may as well say that now. We can't alarm for something that may or may not be in the transport stream. That's the whole way that SCT35 works. A trigger comes along and it triggers something downstream, like a regional opt-out or an add insertion or a vision switch, something, you know, or a play-out device. So the player, you know, whatever's looking at in the transport stream is waiting for these triggers. So not having a trigger is not an error. If we don't know when these triggers are coming, we can't make an error. So there's no sense in which SCT35 produces an error. It doesn't. It purely logs. So we can see all of our logs here, or we can see all of our SCT35 splices here. So we've got loads of them. We've got 1600, in fact. So we can look at any one of these. So we can look at it as a summary. So we can see it in a nice table. We can see when it happened, the avails, not encrypted. So there's a whole load of information that you might want there. If we go to the hex, we can see that we have a download. We have a download button here, and this will enable us to download the binary file. So any of these SCT35 events we can download, and we can actually look at these in a bit more detail here. So it's all here. Everything's here, SCT35. Okay, so that's SCTI35. I don't know whether people around the world call it SCTI35. It's I think it probably is a British thing, because I was talking to my Norwegian colleagues, and when I said SCTI35, they had no idea what I was talking about. So SCTI35, SCTI35. Right, two more very, very quick things to show you. The ability to, now we've discussed this before, but I'm going to explain it once more. The ability to download XML configurations, either the entire configuration or just bits. For example, just the thresholds, just the ETR290 thresholds, for example, OTT configurations, or everything. So we can download those, and if you're doing not maintenance, but if you're playing around with a probe, I use the word playing around, if you're learning how a probe works, or you're adjusting the configuration of the probe, maybe you're changing some of the thresholds on the IP configuration, the Ethernet thresholds. It's a really good idea whenever you're doing any changes to a probe to download the full config. You may as well download the full config, why not? And then you can do as many changes to the probe as you like, and then you can just upload it again here. So you can select that, upload the file, and then the probe is exactly back to where it was. There's one more detail down here, it's the debug data. Sometimes if you have a support call, support will ask you for the debug data, and this is where you find it. In fact, you find it in two places. You can find it here. The debug data can be quite important for a support call. And if we go to the About and we go to System, we can get another means of getting the debug data down here. So we can get that. We can also get the system status as an XML. This effectively gives us the system status. Again, this is something that we can copy and paste and send to support. And it also gives us the ability to see what Linux processes are run. Well, not Linux processes, but the probe is a Linux box, as you probably already know. But it also tells us the Bridgetech processes that are running, and if they're not. So again, the support ticket, the support engineer might ask you for a screen grab of that. So that's the end of today's. I'm going to look at Louise's chat. Let me find out. So I'm going to stop sharing now. Actually, I won't stop sharing just in case. Where are my chats? Where are my chats? Chat, here we go. Can we set a time for the probe to delete these logs from storage? No, Luis, you can't. If we go to data and storage, you can delete selected files or you can delete all files, but you can't, the probe won't delete them from the storage device without manual intervention. What you can do, what does happen is that if it becomes full, actually, do you know what? I don't know. I'm going to make a note and find out for next week. When the SD card gets full, does it delete first in, first out? Or does it, in fact, just stop recording any more new data? So I'm going to find that out. It's probably in the manual. I'll have a look. You can beat me to it. You can look as well. But I'm not going to look now because I don't want to hold you up any longer. We've been going nearly an hour now. But you can delete them. So you can download the ones you want. Remember, download the ones you want to a PC. 32 gig on a PC is nothing. So download them. And then delete them all. You can't download individual files, unfortunately. That would be nice, wouldn't it, if you could download individual files. Okay, guys, so that's the end of this session. Stop sharing, and I'm going to close the session, thanking you very much for your attentions. Remember, the quiz is at bit.ly/quiz_session_8. 20 questions. If you've watched this or if you re-watch it on the video tomorrow morning, and if you look at the manuals, you'll find the quiz fairly easy. Everything in the quiz has been covered in the video today, and if you've forgotten or whenever, just watch the video again, look at the manuals. I always encourage people to look at the manuals. Thanks again, guys, and next week we'll be looking at VBC. We'll be doing a VBC walkthrough. So now the emphasis moves from the probes to the VBC. We haven't finished with probes, not by a long way, but right now we're going to move over to the VBC and start looking at some of the VBC functionality. So thanks for your time, and I hope you've enjoyed it, and see you all next week.